Today's lesson is about how to calculate the volume of a cylinder. A cylinder is defined as a solid with two congruent parallel bases that are circles. Notice how similar this is to your definition of a prism from last class. A prism was defined as a solid with two congruent parallel bases that are polygons. So really the only difference in the two definitions is that now for cylinders, their bases are circles instead of polygons. Because the cylinder is essentially a prism with circle bases, you can actually derive or create your formula for volume of a cylinder from your formula for volume of a prism. Your prism volume is area of base times height of your prism. Now, because cylinders have circle bases, you can plug in your equation for area of a circle, where area of the base is in the formula. For circles, areas is pi r squared. So you plug pi r squared in for capital B, and you create the formula for volume of a cylinder. Volume equals pi r squared times h. Let's use that formula for question 1. So if volume equals pi r squared times h, we could plug in 3, the radius of the base for r, and 5, the height of the prism for h. Now, it's important to follow order of operations or else you might get the wrong answer, so make sure you do the 3 squared, the exponent bit, before the multiplication bit, times 5. 9 times 5 gets you 45. Your final answer is 45 pi inches cubed. Don't forget with volume, your units always are cubed because you're talking about three-dimensional space that fills the inside of a shape. Pause here and try questions 2, 3, and 4 on your own. Check your answer for question 2. And check your answers for 3 and 4. All right, so number 5 is a challenge question. First off, it's a good idea to summarize the information from the word problem on your picture. So they tell us that a lab technician made a 14 diameter hole through the middle of a cylinder. So the diameter of the hole through the middle of the cylinder, labeled at 14. The whole cylinder has a diameter of 20 centimeters, so label the diameter of the complete cylinder 20. And a height of 5 centimeters. So write a 5 for the height. What is the approximate volume of the finished cylinder once the hole is cut out? To figure out how much volume the cylinder has left after the hole was cut out of the center, first find the volume of the whole cylinder and then subtract the volume of what was cut out. One thing I need to point out though is right now you have diameter. Don't forget you need to cut that in half and use radius to plug it in. Pause here and find the volume of each cylinder. You should get that the larger cylinder has 500 pi for its volume and the smaller one has 245 pi volume. So to cut out the smaller cylinder from the larger one, you subtract it. So you should get 255 pi centimeters cubed. Quick note, with word problems, they'll often want the approximate volume. In other words, not pi, but the rounded decimal version. It's roughly 801 when you actually do 255 times 3.14. Sometimes you'll be asked to find the volume of an oblique cylinder or oblique prism. Remember, oblique just means something that's leaning. It doesn't make right angles with the ground. To do that, you're going to use something called Cavalieri's principle. Cavalieri's principle is really pretty cool. It says that if two three-dimensional figures have the same height and the same cross-sectional area at every level, then they have the same volume. So look at these two prisms in the picture here. Because they have the same height and because the cross-section volume is identical, they're both rectangles of the same size, then they have the same volume. Here's an everyday example of Cavalieri's principle. Let's say you have a leaning tower of books. The amount of space that pile of books takes up doesn't actually change if you straighten it out. So these two stacks of books have identical volume. So when you want to find the volume of, say, an oblique prism or an oblique cylinder, just mentally straighten it out and solve like normal. Pause here and try solving for the volume of the two oblique figures below. Go ahead and check your answers. Number 6 is a prism, so this is a flashback to last lesson. You first find the area of the base. Oh, that's 25. And then you multiply by the height of 7. Notice how you're using the actual height, not the slanted side height. How tall it actually is, making right angles with the ground. With the cylinder, they're telling you the diameters too, so make sure you're using the radius, which would be half of that, just 1. And then the height is 3. Plug that in and you get 3 pi cubic meters. Sometimes you'll have a shape that isn't just a prism or just a cylinder. Sometimes you have a combination shape. Any sort of three-dimensional shape that has a combination of pieces to it is called a composite space figure. So when you're solving for the volume of a composite space figure, like in number 8, first split it into its pieces. This composite figure is created of a half cylinder and a prism in a box shape. So you want to find the volume of each of those pieces and then add it up for the full volume of the shape. For the half cylinder, notice how if the prism edge here is labeled 9, that means the diameter of the half cylinder is 9. If 9 is a diameter, then the radius is half of that, 4.5. And also notice how if this edge of the box is 11, that tells us that this edge is 11 for the cylinder, and that would have been the height of the cylinder. So if you plug in a radius of 4.5 and a height of 11 into your cylinder equation and also half it, since it's half of a cylinder, you'd have pi r squared times h all over 2. Plug that in, you get 111.375 pi. And then let's round that to the 10th place. If you actually multiply by 3.14, it's about 349.9. Next, you want to calculate the volume of the prism. So for the prism, the area of the base, which has edges of 9 and 11, would be 9 times 11, or 99. Multiply by the height of 6, and you get 594. So add up those pieces to figure out what the full volume of the composite shape is, roughly 943.9 cubic millimeters. Well done, everybody. Don't forget to turn in a picture of today's notes.